Everyone. I would like to thank the organizing committee and the chair of the session to give me a chance to present my work. So my title of the paper is the voltammetric estimation of thiophanate-methyl by electrochemical investigation of copper thiamethyl reaction in fungicide formulation and agriculture produces. So as you know that pesticide is important, inevitable input to the agriculture, modern agriculture. But at the same time, we are facing various environmental issues because of the use of the excessive and non-judicious use of these pesticides. And India is one of the largest consumer as well as the producer of these pesticides. And these pesticides going to be important, and because of that, we have to have these certain methodology that has to monitor the different types of the pesticide residue in the environmental, and for that purpose we have to have different methodology that should be adopted for the same purpose. So if you look into the one of the important pesticides that known to be a thiourea based pesticide, that known to be a thiophanate-methyl, this is basically a systematic broad spectrum fungicide. It used to inhibit the fungal cellular growth of the fungus, which used to act as a pesticide for pest for the damage of the various agriculture as well as the horticulture crops. And if you look into the different metabolites of this pesticide, you will find that it get decomposed and break down into variety of the harmful materials, which known to be metabolites, which include the carbendazim, benzomyl, and some other important metabolites. So because of these, there are certain human health effects which may be going to prove to be carcinogenic. There are certain environmental effects because of the accumulation of these residue in different state of the environment. And similarly, they are important because of the regulation consideration for the safe use of these pesticides. So in view of the present situation, the pesticide analysis is one of the important aspects because of the health aspect, because compliance of and the regulation aspect is very important. And similarly, you might have been listening about the spices cases, that international trade is very important, where we can ban certain amount of food stuff if it is not following certain limits, residue limits, similar to the environmental impact which because of these pesticides. So for that purpose, we have to have certain sensitive methods for these pesticide monitoring and their analysis, because so as to follow the pesticide management practices properly to safeguard the environment and human health. So if you look into the pesticides, this thiophanate-methyl, we have been using lots of the methodology, analytical methods for the analysis and monitoring of these pesticides. But when we look into certain limitation of such methodology, just like spectrophotometry and chromatographic techniques, we found that these methods are somewhat tedious and time consuming, and the results are not going to be that much accurate one. And you can see that it involves cost. So these methods are not that much cost and time effective. Therefore, we are looking for certain alternate methodology, certain analytical methodology. So one of them is the voltammetric techniques. So voltammetric technique is nothing but a technique where we used to apply the controlled potential, and we used to measure the respective diffusion current which is produced because of the electroactivity of that particular analyte, that is the pesticide. So here we used to have the analysis of the thiophanate-methyl, which is one of the important pesticides. So here in voltammetric system, we have a electrochemical cell which is consist of 3 electrode system. One is counter, another is the working electrode, which will sense the concentration of the analyte, and the another one is the reference electrode. So this is going to be important, how you use to optimize the reaction condition for the analysis of this pesticide. So you have to have the optimization of the suitable coating electrolyte system, and if the system, if analyte is not electroactive, then you have to have the derivatizing method which can sense that particular analyte. Similarly, you have to have the suitable working electrode system which should sense that particular analyte. Okay, otherwise you have to change the working electrode system if you are not getting the suitable response. So basically these voltammetric techniques have been widely now used for the pesticide analysis because they provide qualitative as well as the quantitative aspect of the pesticide in different residues, and at the same time they can be used for electrochemical characterization in terms of the electrochemical behavior of the species and how much change is involved during their degradation process. So ultimately we used to obtain by this technique the voltammogram, which is very important, and we used to interpret the voltammogram for these cited parameters, and which help us to find out the various types of the aspect, including the mechanism by which it used to undergo. So this method, this pesticide is important, and we used to have the voltammetric investigation, and the basis of this investigation is that when we took the copper perchlorate as a reagent and we used to add the analyte to this mixture, then there is a formation of a diffusion controlled peak, which is comparatively more sensitive as compared to the simple analyte. So we explore this property of this reaction because when we have the analyte, that is the thiophanate-methyl, it used to produce the peak at 140 millivolt. But when we used to have the reaction between copper perchlorate and analyte, that is thiophanate-methyl, it used to produce an enhanced peak of the higher or you can say the greater sensitivity, and therefore we can detect the analyte up to lower level. So this has been made the basis for this whole investigation. And why it is happening so you can see we have, when we add analyte to the copper reagent, there is a increase in the sensitivity of the method. This is because of the formation of the copper 3 complex. So this was further confirmed by the cyclic voltammetric studies. So this is the cyclic voltammeter of the copper 3 complex which is formed. So you can see that this undergo the reduction and oxidation process, and during this process the one electron change is involved. So this further supported by various literature as well as the cyclic voltammetric studies, and even the bulky group which is present on this complex, that is the perchlorate, and used to stabilize the higher oxidation state of the copper 3. So this is well cited in the literature. Similarly, the IR study also supported the proposed mechanism for the reaction. So this is very important, and this is going to be responsible for the higher sensitivity of the method. So this method has been further applied to the formulation analysis as well as to the residue analysis. So these are the merits, figure of the merits of the voltammetric investigation, that we can analyze the compound up to lower level up to ppm level, and there is a broader range of this method which can be applied from low to the higher level. If you look into the different investigation regarding the formulation analysis, so you will find better results in terms of.
Hello, sir. Okay.
Yeah.
The screen is visible?
Sir, please.
Okay.
Yeah, just yeah. This method is simple, rapid, because it is not require any extraction processes. It has a greater sensitivity, and this is going to be important because it also provides the most plausible mechanism for the reaction that is going to take place during the whole reaction, and it has a better reproducibility and can be applied to formulation as well as to the residue analysis. This is all about my presentation. Thank you very much.
Department of CSE, Ravindra College of Engineering from Kurnool, Andhra Pradesh. Sir, am I audible, sir?
Yeah. You can start.
So my research domain is an integrated privacy preservation ML model for distributed large-scale real-time applications. So today I would like to talk briefly about high-dimensional data and the importance of advanced feature extraction techniques. So here, high-dimensional data in the sense it's a layered data which involves data sets with many features or variables, increasingly common in various fields such as genomics, image processing, text analysis. While these data sets can provide rich information, they also pose significant challenges. And we need to overcome such problems. What exactly this high-dimensional data and how we are going to be extract the features in this particular things. All these comes under in this particular paper, sir. So next one is an abstract. Abstract related to what exactly existing mechanism there in this, and we are having a wide range of survey over that, like what is the linear instrument analysis, and what is the principal component analysis, what are exactly the problem there in there. So we done all those problems and all, and we come to some conclusion that we are having a stochastic enriching things and ISO maps and locally linear embedding technologies and all these things. So based on this particular abstract, we are moving towards the next introduction. So what exactly to be extract the features. Feature is an individual measurable property or a characteristics of a phenomenon which is being observed. Input variables used by a machine. So take a simple example of a discriminate bodies of each and everything are going to be identified, and what the features are properly. So based on that, the machine learning algorithm is able to give accurate results. So, yes, sir. Here, we need to have all the features. If more features are going to be considered, definitely it leads to some complications. What are the features we require? What are the features really make part or will address the efficiency? Those things we need to consider, and we need to reduce the features by calling a dimensionality reduction is a separate mechanism. So there can have two approaches here in order to extract the features, in order to identify the features. Those are the feature selection and feature extraction. So what is the feature selection? Feature selection is the process of selecting the subset of relevant features. So you consider that we are having some features of a particular object. So what are the features you are supposed to identify for a better efficiency by means of a machine learning algorithms? So we are going to be select those features. There we can have three different mechanisms. First one is the filter method, wrapper method, and embedded method and all. So here, the filter method, which is used statistical measures to independently assess the feature relevance. Coming to wrapper, which evaluates feature subsets through predictive models to find the optimal combinations and and embedded method, which is integrated feature selection into model process. So next one is the feature extraction. So the process of transforming a space from space to required space, so multi-dimensional space to 2D space like this. So you are considering a given object and transforming into a different space. This approach is used over here. Here it is useful when you want to keep the whole information. You are considering all the information, but very fewer resources or fewer properties are only required. Then we can have different approaches in this, like PCA, principal component analysis, linear instrument analysis, kernel PCA, quadratic instrument analysis, and all these are the separate models were in this in order to extract the features. So next one is the ensemble approach. So here the survey gone instead of applying a complete one algorithm for extracting the feature and giving efficiency, there you can have a different approaches. Means you are using not a single algorithm or single model. You can go for different models for a different kind of features and all. So there you can have three approaches here. The first one is the bagging, boosting, and stacking. So in this particular notation, so different kinds of machine learning algorithms are going to be applied for based on the efficiency and all. The first one is the bagging. The name itself says it is a bootstrap aggregating. And here, whatever the features you are extracting, whatever the features you are considering from the original data, you are going to be distributed among just like a cluster wise and assigned to the machine learning algorithm on just like a parallel way. And collecting all the predicted values, aggregated those, and give the final accurate results. This is as same as boosting. In a boosting, whatever the features you are giving to a particular machine learning model, that model will predict and give some result. If anything which is not unable to predict or which is not helpful for that particular model, those things will be again sequentially given to another model in a sequential way. So one model gives a result, and that result is acting as the input to the next model, and so on. Coming to stacking, stacking is another efficient model here. The information given different algorithms simultaneously, they apply all the information and generate the result. That will be given as a second level algorithms and so on. Finally, we are going to predict the accurate results. These all comes under ensembling approaches. So coming actual, what exactly a multi-level data, how you are going to be extract the multi-level features and how you are transforming this come over here. In a multi-level data, the data is just like the hierarchical way, having a different levels, right? This hierarchical data or multi-level data is organized into multi-level tiers or layers. Just like a student, if you take a student example, the student, they can have a student class, student sections, like that you can have a different layers. Every level or layer is responsible to have some features. So we need to have maintain all such information in a layer by layer approach. And next is we need to have the challenges, what traditional machine learning approach is there for this multi-level data.
Can you control fast?
Sir?
Make it fast so that we can control.
Okay, sir. Next one is multi-level dimensional. Here, you are just accepting all the multi-level layer data and you are giving to the next approach in order to reduce the dimensionality. So those features which is relevant and which is not playing major role by predicting accurate results, that comes under multi-level dimensionality reduction method. Here you can have some approaches like hierarchical principal component analysis and MFA, HNF, and so on. And next is the feature extraction. Whatever the data given, just you have to go for the pre-processing, and next level you extract the features and given to the cross-level integration, and then go for the dimensionality reduction. And final phase is evaluation. If machine is able to identify or able to generate a result in a better way, you are going to be considered such things. Or else you are just reiterating the same process continuously until you get a accurate results. So I would like to conclude that the scenario over here is whatever the feature you are considering in a normal scenario, but in a coming to multi-level, we need to have a layer by layer approach, and we need to have appropriate feature extraction, and we are going to be integrate all those things and give a better efficiency by means of different approaches of machine learning algorithms. Right, so these are the references which I mentioned here, and thank you all for patient listening.
Speaker, myself, Professor P.K. Satapathy, Head of the Department and Professor of Chemistry, MSP University, Paripada. Now I am going to deliver a talk on synthesis, characterization, and application of the reduced graphene oxide seriatignia composite for the removal of heavy metal ions from the contaminated water. We know nowadays the drinking water have a lot of problems. It has lost lot of contaminants, and we know the primary source of water pollution are the industrial effluents which are discharged from the industries, and again the heavy metals also cause some pollution for the water. And among various types of heavy metals, arsenic 3+, cadmium 2+, lead 2+, and cobalt 2+ are constantly present. After introduction of contaminating the food chain, they causing different health problems due to their toxicity. Therefore, we are aimed to synthesize the adsorbent and to study the adsorptive removal of these heavy metals from the water. Nowadays, there are a lot of techniques to remove the effluents. among all the techniques, the adsorption is the simple or the cost-effective technique. So adsorption technique is tremendously proven to be highly effective and acceptable by researchers, as this method is less expensive and its operation process is easily accessible with simplicity. The most important advantage of this technique is its insensitivity towards toxic materials in comparison to other conventional methods. So the present work is to synthesize the graphene doped seriatype mixed oxide nanocomposite and to study the absorption efficiency of these material towards absorption of lead, cadmium, arsenic and cobalt. Now come to the synthesis part. The graphene was synthesized by thermal method, and the series of seriatype mixed oxide was prepared by varying seriatype content by the graphene and seriatype composite were prepared by chemical. And these samples are tested by HID, FTIR, beat, surface area, U visible DRS, and other techniques like ACM, TEM, etc. Now come to the XID part. So the XID data gives that there is a homogeneous mixing of this area with the titanium, and there is no extra phase for ceria. That means ceria is mixed with the composite, and if you compare the 2%, if the code is DCTO5 means the graphene ceria titania, 2 means ceria component is 2%, 5 means ceria component 5%, and the 10 means ceria component 10%. And these are the samples were characterized by XID. And come to the adsorption study, in that the 2% ceria composite material possesses higher surface area, and also it has a high pore size. Therefore, out of the 3 samples, the CTO5 sample was taken for adsorption study and further studies because of its crystallinity and high surface area. So it is more active towards the adsorption process in comparison to other 2 samples. Next, the invisible DRS. The invisible DRS spectra it gives the value of invisible DRS spectra is evident that the proper doping is taking place in the 5% ceria samples. And again, the FESM study indicates that it has a nano surface size, or it is best effective for the adsorption process, and the DX data gives that to the carbon content is 4.56%, oxygen 22.36%, titanium 69.54%, and ceria 3.59%. Let's come to the FTIR study. The FTIR study indicates that the FTIR study was taking from 4000 cm inverse to 400 cm inverse, and at 3400 cm inverse there is a peak of OH stretching. The widening of the peak is due to the surface attached OH group. Similarly, at 1303.5 cm inverse we are getting a OH bending peak, and again in the 400 to 700 cm inverse range the metal oxide peaks are obtained due to metal to oxygen lattice vibration, and maybe due to the MO stretching and bending modes. Similarly, the Raman confirms the composite formation between the metal oxide and the RGO. Next, come to thermal studies. And the DLS study indicates that it is used for the analysis of hydrodynamic diameter of the sample to check the state of agglomeration due to course of activity and during the dispersion of the liquid. The sensor due to GCTO5 is accompanied hydroxide. Therefore, taking the GCTO5 sample for the adsorption study. Then the thermal analysis indicates the TGD curve indicates that the major weight loss is in between 95 to 90 degree, indicating the loss of entrapped water molecule from the surface of the. A very lower percentage of degradation can be seen between 350 to 500 Celsius, and indicating the loss of organic functional group like OH group, C-carbon. Now we are going to the adsorption study. How adsorption of these four metals ions taking place by this adsorbent. So the preliminary study we are taking a fixed amount of the adsorbent. We are taking 20 milligram of adsorbent at pH 5, and we are taking metal ion concentration 5 ppm. In each case, it is found that the Rec2O5 sample gives higher percentage of adsorption in comparison to other two samples. Therefore, the Rec2O5 sample is taking for other variation of other parameters. Again, it is indicated that at 75 minute time interval, we are getting a saturation point where maximum adsorption taking place, and after that time again it decreases. Therefore, 75 minutes taking is taken for further variation like pH variation, like the concentration of metal ion variation, like the adsorbent dose variation. Now, in the effect of pH, it indicates that by increasing pH, the percentage of adsorption increases, then decreases. And this thing happens for cobalt, for cadmium, and lead. But for arsenic, at 3 pH, it indicates higher percentage, and by increasing the pH, the percentage of adsorption gradually decreases. It depends upon the pH pH value. The pH pH value is 5.6, around 5.6. In case of arsenic actually in 3 to 5 pH range, has 10%. So these negative what the pH is increased, the adsorption gradually decreases. Similarly, when we are taking the percentage of increases because of the increase of the active side. Similarly, if we increase the concentration of the metal ions, the percentage of adsorption gradually decreases because the trapping of the pores. The first in cases, okay, so by increasing the concentration of the metal ions, the percentage decreases. But the weight of the adsorbent, the percentage of adsorption increases. And again, we are taking into account the adsorption isotherm study or kinetic study. From the kinetic parameters, it indicates that the samples of the adsorption process obey both Langmuir and friendly isotherm, and they obey the pseudo second order kinetics. It is indicated from the R square value from the different plots. Let's come to conclusion. So the study indicates that the Rec2O samples can be applied as adsorbents for the expulsion of excess cobalt 2+, cadmium 2+, arsenic 6+, and lead 2+ from the water bodies. The percentage of adsorption of metal ions rises with an increase in amount of adsorbent owing to an increase in amount of adsorption declines with the rise in concentration of adsorbent at a constant amount of adsorbent, which may be due to blockage of the pore size of the adsorbent. Further, arsenic 3+ shows maximum adsorption at pH 3 below the point of zero charge, value of 5.4, and other metal ions show maximum adsorption at pH 6 to 7. And these adsorption processes obey both the Langmuir and friendly isotherms and obey zero second order kinetics. These are the students who are working in my group. Thank you all for your kind attention.
Everyone, and I'll be presenting this experimental work on chemical resilience of glass reinforced polymer pipes for sewage applications. This is an actual industrial applied project, and I'll start with the background of this project. As we know that sewages are very important for our residential infrastructure, wherein whenever there is rain and waterlogging happens, we see a lot of waterborne diseases. So to avoid those things, it's very important for us to have a good sewage infrastructure. And I personally sort of feel about it because very recently in Dubai there was a lot of rain, and after that we had dengue spread here, and I was one of the patients who struggled for a good 1 month. So it's very important for us to take care of sewage wherever we have residential compounds. So in most of the currently sewages that we have, these are made of bricks and stones and concrete. But there are issues that happen on these sewages, which is mostly coming from H2S attack, corrosion happening, or structural loading, that is in terms of dead load, vehicular load, or impact load. So there could be some damage that happens in places. And it becomes sometimes difficult for us to fix those damages, especially when there are running traffic and those kind of situations. So rehabilitation of these sewers becomes very important. And one of the, you can see in these pictures, these are the pictures of live projects from USA where sewage rehabilitation work is going on. So one substitute for the conventional material is glass reinforced plastics. And why we sort of use glass reinforced plastics is that because they have this multi-functional capabilities. They are structurally strong, they have a good chemical resistance property, and they are lightweight in nature. On the other side, they are not as brittle as concrete and conventional materials, so that they reduce the chances of brittle damage. And many of the places, the sewages are planned in such a way that the geometry or the cross section of sewage could be very different from the conventional circular or rectangular geometry. So to fit in those places, we can custom fabricate any size, any shape that we want using add-layers method. And when we think in terms of the transportation of these custom-made pipes, because they are light in nature, and we can divide them in multiple segments also. So overall, in terms of transportation costs also, we can reduce. So what we are doing in this project is we are using a custom-built GRP composite, which has 6 layers there, and each layer has its own purpose there. So internally, the first layer there is your L1 layer, which is a smooth water resistance layer, so that the water or the sewage flows smoothly inside there. This is approximately 0.5 mm, and this is made from glass fiber surface tissues. The next layer is called barrier layer, which is for a structural load as well as the chemical resistance. This is made of chopped strand mat. The thickness of that layer is approximately more than 1 millimeter. Third layer is called interior layer. That is again a mix of chopped strand mat or unidirectional or bidirectional mat. This is slightly thicker. Thickness is around 2 mm for that. And then in between, what we do is to make the thickness bigger and then increase the bending stiffness of these pipes. We add a layer which is made of blended sand and some resin there. This is just to add thickness to it, so that the stronger layers, which are glass fiber layers, are sitting away from the center line of this. And the thickness of this varies based on the project that we are working on, but generally speaking, this is going to be more than 10 mm. Then we have an intermediate layer, which is again made of chopped strand mat or UDM or VDM layers. This is again slightly higher than 2 mm. And at the outset, we have this external layer, which is made of silica and resin, around 1 to 3 mm there. So each one of these layers are carefully made, carefully selected materials, and this is a GRP composite, which you can treat it as a sandwich structure. So what are the objectives of this work? The objective of this work is to examine the chemical resistance of the individual layers that are making this composite, as well as looking at the composite as a whole and seeing what is the effect of different chemicals on this composite. And how do we select which chemicals we are going to use for this study? There is a California Green Book, which is for sewage rehabilitation work, and as well as there is an Australian standard AS 3572.2, which gives a list of chemicals. Right. So what are we doing as a testing here? We are conducting these experiments where we expose these samples in chemicals for a long duration of time, and in a sequential manner, after a periodic time, we take the weight of these samples to see what kind of weight loss we are observing there. And once the whole test is complete, what we do is, before the testing starts, we do one tensile test to see what is the strength of the composite. And after the whole chemical exposure testing is completed, we do another tensile test to see the degradation that this chemical exposure is causing. So the chemicals that we have selected for this study can be categorized into 2 categories. One is coming from the sewage liquid that is present in the system. And there are 4 chemicals or liquids that we use for this testing. First one is sulfuric acid, second one is sodium hypochlorite, third one is sodium chloride, and the last one is distilled water, which is present in the sewage in any way because of over usage. The other segment that the chemicals that we are using in the study are mostly coming from the manufacturing process of composites, because many a times when you are installing these pipes on live projects, you take multiple segments and then try to assemble that pipe, or you try to join at least two pipes along the axis of it, so that you can complete the structure. So in that manufacturing process, there are some chemicals that are used on site. So we have used those chemicals also to see the effect of these chemicals. And these chemicals are MEKP. MEKP is a curing agent. Then we have cobalt octave, which is used as a catalyst. And then we have DMA. DMA is a accelerator that is used to speed up the reaction that's coming from the cobalt octave. And then we have acetone. Acetone is used mostly for cleaning purposes, and you will see that how bad this acetone could be from the chemical exposure perspective. So now what we do in this, we prepare the samples using conventional molding process. You can see in these pictures right here. You prepare these, this is the process for individual layers. I have discussed those 6 layers. So for each layer, we are making compressible molding specimens, which are looking of, let's say, this nature. The dimensions are 1 inch by 3 inch. And what we do after this is that we put them in desiccators before we start the experiment for 3 hours, so that the moisture and everything is cleaned out. Then we start doing the weight loss experiments. So these are the let's say these are the boxes that are prepared where we have filled this chemicals, and these are all the chemicals lined up here, and then we expose these samples individually in these. So there are 6 layers, so you can see 1, 2, 3, 4, 5, 6 samples are there, and 1 sample there is which is as a composite as a whole. So the standard that we are following for this test is the STM D543. Now coming to the results, this is the weight loss data that we have got for individual layers. So we have one isophthalic resin layer there. For this layer, you can notice that the significant weight loss is happening mostly because of sodium hypochlorite. And another thing that I wanted to notice is that all the chemicals that are being used as a manufacturing process chemicals, all of them are not reducing the weight, but they are increasing the weight of the samples. Similarly, if you notice in terms of the weight loss for the chalk strand mat, you can see that the weight reduction is happening for all the chemicals except for MEKP, DMA, and the cobalt octave. The percent reduction is very small, which is about 1% after completion of 180 days. Now the next 2 layers is blended sand. This is a porous layer because we are mixing sand with resin, so there is a lot of void content there. So what we notice while we do experiment is the sample starts sort of some sand particles start chipping away from the samples. That's why you can see that for all the samples here, you can see a consistent reduction in all the samples here. This one is unidirectional mat. In this case, also similar to the CSM, we notice that the weight is increasing for MEKP, DMA, and cobalt octave, but for all other samples, your weight reduction is happening in the range of about 1% at 180 days. The last one, we have the surface tissue and the ARF layer. Surface tissue is also, let's say, a single layer of glass fiber that we are using there. Similar pattern is noticed here, but slightly higher weight reduction here is about 1.5%. Now this one, ARF 60%, this is an adhesive that was prepared only for this project because we wanted to recycle the glass fiber that we are using in the whole project. So this ARF is basically the waste that is caused during this project. We are using that waste, chopping it into small fine particles and mixing it in some adhesive so that we can improve the efficiency of the load transfer while we are joining these components. So we have tested that ARF layer also individually, and we have noticed that the weight loss is much lesser compared to other layers. Other layers are going around 1 to 1.5%, but in this case, the weight loss is only about 0.35, 0.4% in that range. The last sample that we have tested for this purposes, we have combined all the layers that were there in this GRP sandwich structure, and after using the same hand layer process for all these layers, we have prepared these specimens, weighted the specimens before the test, and then we have measured the weight of the samples after 30, 60, 90, and 180 days. Same chemicals were used for this, and same standard were used for this. Now, looking at the data here, you can see that the most damaging chemical that we have noticed here is that acetone, for which the overall weight loss is about minus 1.5% here, or weight loss is about 1.5% here. But for all other chemicals, you can see that weight loss is very insignificant compared to this here. Only about there's an order of roughly 10 difference here between these two. So now, what is the summary from this? We can say that the chemicals that we are using for manufacturing processes, they are not reducing the weight, and mostly this is happening because MEKP is a curing agent. So when we expose these samples to MEKP, there may be polymerization that is starting to happen there, and new bond formations may be happening there, and that's why there could be some weight uptake or weight increase happening. And similar thing can be said for the accelerator and catalyst there. Now, in the case of sulfuric acid starts working as a hydrolysis agent, and some of the bonds that are there in the region and the polymers there could be broken there, and that's why we see some weight loss there. And we have seen a lot of weight loss because of NaClO, and NaClO behaves as a oxidizing agent. Because of that, again, the resin goes through damage, and that's the reason we notice these weight losses there. In the case of blended sand layer, we see the highest weight loss, and there are two reasons for that. One is there's a resin present there in the system, and that is maybe eaten away by acetone. And the second thing is because it's a porous structure, so we see sometimes that some of the sand particles and sand layers are, and in some cases, we have noticed that the blended sand specimen breaks also into two pieces. Okay, and for the GRP sandwich structure, acetone shows significantly higher weight loss compared to other samples. And as a substitute, because acetone is used for all the cleaning purposes while we are doing manufacturing. So from that perspective, we need to find a substitute which can be used for acetone, and there is a substitute available in the market which is known as TriClean, which is going to help us in this process, because this is a constant ongoing project. So we are exploring those ideas there. In some of the samples, when we expose it to acetone, there was some fungus also, it was noticed there. Other than that, there was no physical damage or anything available on the surface, except for those surface tissue or the thin specimens that we have. Because of moisture uptake, we have noticed some of the samples being folded. So if you notice one of the pictures here, this one right here, you can see that this specimen is completely folded after exposure to moisture there. And for the GRP specimen specifically, because of moisture uptake, we have seen noticeable swelling also happening in these specimens. So what is the future, let's say, direction for this project? As I said in the beginning, we have to test these samples after exposure of for the strength purpose also. So we have done the testing for the unexposed samples already. We have that data. Currently, we have these samples exposed in the chemical, and we are waiting for some more time so that 90 days are over. So we have gathered data for 30 days, 60 days, and 90 days. We are waiting till 150 days to complete this process. The standard that we are going to use for this is ISO 8531, and these samples were created as a multi-layer sandwich structure with an adhesive joint right at the center here. So that's all from my side. I am open for any questions. I hope I have finished in the time.
First of all, I would like to thank the organizer for accepting this paper and giving us chance to present our paper. Our paper is on green development of ABS nanocomposites through reduced graphene oxide, that is RGO, extraction from plastic waste. This graphene oxide earlier it was made with many techniques and standard material is there, and now with the help of plastic waste, this reduced graphene oxide is being made. And as we all know that this plastic waste is creating a lot of problems. So this is one of the solution for using plastic waste by converting it to RGO. And just I will skip a few slides early. This is a methodology where this plastic waste is converted into reduced graphene oxide. This was patented by Dr. Sahu and Mahesh Babu and Punitha Saab, and they've done this by two process reactor. First with the primary bed reactor and with secondary bed reactor. One was at 400 degree and another was at 850 degrees centigrade. And these GNs are now stacked, and ultimately this graphene oxide is being produced. This is the methodology which in a plant where they have produced RGO, and from there we have collected RGO and done various analysis. So it is done by first pyrolysis method, then by second process it is done by this BLF furnace, and last by jet milling. By jet milling it is grinded, and we are getting the desired value in nanocomposite, in this nanocomposite. So this is RGO and thermoplastic material. It is a polymer which is widely used for electronic item and even in automobiles. So we have tried to enhance the properties by adding RGOs to ABS, and this is our research objective. First to prepare this multifunctional nanocomposites based on thermoplastics with various loading of RGO, and then to investigate various properties, that is mechanical, thermal, electrical properties of these nanocomposites, and the comparison of these results, and development of high performance materials with specific reference to the high-end application in different fields. So for our research activity, we have taken raw material ABS, which is Epsolac 920 grade injection molding, having a melt flow rate of RGO. Sorry, it was around 17 melt flow rate was there. It was not mentioned. And then RGO, which is the number of layers are 2.5 thickness. It is given 1.2 to 1 nanometer. And core diameter is 2.154 nanometer. And first we have done melt mixing with the help of two-roll mill, and we have taken different loading 0.5%, 0.75%, 1%, 1.5%, and 2% of RGO. And with this, we have made different materials, different specimens, and the temperature was maintained at 180 to 200 degree, which is suitable for ABS. And the machines which we have used is a compression molding machine. We will not going into detail. This is the fabrication of nanocomposite specimen. ABS and RGO we have made in two-roll mill. Then it is compressed in a compression molding press. Then we have made a compressed sheet, and with the help of dumbbell cutter, we have cut the specimen of different sizes as per the ASTM standards. Now, testing and characterization, we have done tensile testing, structural properties, impact properties. Then we have done hardness testing and electrical properties, dielectric strength. We have done for this different compositions. Then TGA, thermogravimetric analysis, and DSC, differential scanning calorimetric analysis we have done, and all these results has been taken, and we have analyzed, so that if we go through one by one, if we ABS virgin, then ABS 0.5% RGO, then ABS is 0.75% RGO, then 1% RGO, 1.5% RGO, and 2%. These different combinations we have taken, and we have studied whatever these results have come, that we have tabulated. And if we see this, then with 1% RGO, we are getting optimum result. Like in tensile testing, tensile strength MPa, it has gone from 43.3 of virgin ABS to 44.3. Similarly, tensile modulus also 2290 to 2240. Flexural strength also 56.67. And modulus, there is a very good increase in phenomenal increase in modulus, flexural modulus, which is almost double, 1400 to 3000, 16.6, more than double. And iodide impact and all, there is slight variation. And hardness, if you see, hardness also it is increased in 1% combination of RGO, which has come to 79 against 76 in case of ABS virgin. So this is in graphical form, bar form. This is what our document we have received. Then the this is the data sheet which we are able to get the different readings, what I have told earlier also. And there is very good enhancement in flexural strength as well as flexural modulus as 61.47 and 307, we show around 66% and 135 increments. So this is very good result we can say, because if we are mixing ABS to if we are using ABS and mixing RGO, we are getting very good mechanical properties, which is indeed needed in all auto components, automobile components, where like battery case, also it is made of ABS material, and other applications also in electronics and in automobiles also. So there this mechanical property is to be increased, especially in flexural and other properties. So this ABS we can see it is having good results. Similarly, when this DSC analysis, if you see with 1% RGO, this DSC is also stable. We can say 108.62, which was 107.90. So not much deviation is observed in DSC. This is DSC curve. In TG also, ABS virgin is 0.412%, but here this TGA is also when we are observing higher thermal stability due to this CC bond, carbon-carbon bond, which is due to reduced graphene oxide. This is the graph of TGA, and the dielectric strength. If you see here, so the dielectric strength in ABS virgin is 7.87. But if you are adding RGO, it will act as a conductor. Even though if you are with the 1% RGO, this conductivity is even maintained 7.42. If we are increasing the RGO content more than 1%, the conductivity is further decreased. So here also, if you see from 7.422, it is going to again 7.16. So up to 1%, this conductivity is resistivity, dielectric strength is maintained, and we can say it is a good result. So if you see the conclusion, then with the help of this RGO, we are getting good mechanical properties, and this can be used for cost-effective prospect in automobile industries and 3D printing filaments also. Because these 3D printing filament ABS are now being used, so if we include this RGO, then this strength-wise we can get good design material in the 3D printing. Then plastic, it is a low cost as compared to commercially available graphene and RGO, because it is derived from plastic waste, and it is also one solution for plastic waste elimination in the country. And it is that's why it also plays an important role in circular economy. And sustainability and environmental benefits are always there, as it is reducing the plastic waste, and in turns whatever product is coming, it is increasing the mechanical properties of engineering plastics like ABS. So these are the various references from where we have taken, and this project we have got through NRDC, who has given us financial support for doing all this analysis. So thank you very much to all of you, and any question is there.